Hello, students. Welcome to our next lesson. This lesson is about acceleration. We're going to learn acceleration, and we're going to learn free fall acceleration due to gravity. All right. Acceleration is defined as a change in velocity of time. Remember, we defined velocity as directed speed. So we need to know the speed and the direction for us to describe velocity. So when we say change in velocity, what do we mean? So the change in velocity can occur if we have a change in speed, or if we have a change in direction, or both. So whenever there is a change in speed, or maybe a change in direction, or both, then we have acceleration, right? So when we move in a straight line, our focus is on changes in speed. But when we are rounding a curve, for example, our focus is on changes in direction. When the direction is changing, we have actually acceleration. We are going to represent acceleration mathematically or in equation form as a change in velocity divided by change in time. We are going to write change in as delta. The little triangle there stands for change in. So delta V divided by change in time. This one will be delta T. So acceleration is delta V over delta T here. And we can try to solve one example here. For example, if your car's speed changes from 35 kilometers per hour to 40 kilometers per hour in 5 seconds, what will be the acceleration? So you're going to look at the change. What does the change mean? So change in V divided by change in time. So a change means that you have to take the final value minus the initial value. So the final value of speed is 40 kilometers per hour, and the initial change in value is 35 kilometers per hour. Then you divide by the time, which is 5 seconds. Notice here that we are thinking about linear motion. So this is a linear motion. So we should think about linear motion. All right, so this discussion pertains to linear motion. So the speed is changing whilst the car is moving in linear motion. The story might be different if we talk about curved motion. We'll handle that later. For now, our focus is on linear motion, and we can simply say 40 kilometers per hour minus 35 kilometers per hour divided by 5 seconds. And that will be our acceleration. Usually, some people call this an average acceleration, but we are going to stick to acceleration. Okay, so let's continue solving for our acceleration. So acceleration will be 5 kilometers per hour, which was 40 kilometers per hour minus 30 kilometers per hour. So the result on top, the numerator will be 5 kilometers per hour divided by 5 seconds. Now we see that if we divide 5 by 5, we get 1. Then there's a kilometer on top, slash, there's hour, and then a second remains there. So we have h dot s. Those ones will be the denominator units. So our acceleration is 1 kilometer per hour per second. So what this means is that the car picks up a speed of 1 kilometer per hour every second. So it means the car picks up a speed of 1 kilometer per hour every second of travel. So that's what it means. When you say the acceleration is 1 kilometer per hour per second, it means the car picks up a speed of 1 kilometer per hour every second of travel. All right. So you can tell its velocity at a later time. For example, let's say someone tells me that right now the car is traveling at 50 kilometers per hour. Then after 1 second of travel, then the speed will be 51. You're going to add 51 here because that's what it means to accelerate at 1 kilometer per hour per second. After another second, here we'll see the car at 52 kilometers per hour. All right. After another second, it will be at 53 kilometers per hour, and so on. So you are adding a speed of 1 kilometer per hour every second of travel. So it will be 0 seconds here. That's initially, and then after 1 second, 1 second of travel, you got this, and after another 2 seconds of travel here, and then here will be after like 3 seconds of travel. So every second you are adding 1 kilometer per hour to the speed. So this is just an example, and the meaning of acceleration is very important for you to understand. All right, so let's see. Okay, so let's move on to free fall. When objects are falling, and the only force acting on them is gravity, they are said to be in free fall, falling under the influence of gravity only. Experiments, observations show that when objects accelerate freely, they do so at a rate of 9.8 meters per second squared, which we approximate to 10 meters per second squared. So you can read this. Sometimes people write this as 10 meters per second, right? So the meaning is that the object picks up a speed of the object picks up a speed of what? Of 10 meters per second every second of falling. So every second of falling. That's what it means. So if the object is falling to the ground, it picks up a speed of 10 meters per second every second of falling. We are going to also think about what happens when we toss an object and it's going upward. What happens to its velocity? At that point, we will see that when objects are going up under the influence of gravity only, they lose the speed. They lose a speed of 10 meters per second every second. So they lose the speed. When they are falling down and free fall, they gain the speed. All right. So let's see the symbol. We are going to use acceleration due to gravity symbol as G. Some people call it gravitational acceleration, but for now we're going to use G. I know it can be confusing. It doesn't stand for gravity. It stands for acceleration due to gravity. So G equal to 10 meters per second squared is the common number that will be used a lot in different labs or in different chapters. Okay. Now let's think about what happens when objects are falling freely from rest. So this is falling from rest, falling from rest, falling from rest. So I'm thinking about initially when time is 0, the velocity will be 0 because I'm falling from rest. Then after 1 second of travel, the instantaneous velocity will be 10. At 2 seconds, instantaneous velocity will be 20. At 3 seconds to 30. So as you can see, I keep on adding plus 10. So plus 10 here, plus 10 here, plus 10 here, plus 10 here. I'm doing this because I know that acceleration due to gravity is 10 meters per second squared. That's why I am doing that. In general, you can just use this formula here. If you want to find the velocity of a falling object, you can just use the formula V final equal to G times time. You might have, for example, falling for 100 seconds. That would be difficult. It would be tedious to build up this table. In that case, you just say v final will be, let's say time taken is 100 seconds. You just have to multiply 10, multiply by 100 seconds. Your answer will be in meters per second. So this will give you 1,000 meters per second. That will be the final velocity of this falling object. Let's look at average velocity. Can we find the average velocity or average speed? By the way, we are going to use speed and velocity interchangeably if we are focusing on linear motion, because direction is obvious. So speed and the velocity can be used interchangeably. So we are looking at what would be the average velocity, for example, after falling for 4 seconds. So time here is 4 seconds. So what would be the average velocity for an object that falls for 4 seconds? So when we do that, we have to think about how do we find the average of numbers. So here we have 1, 2, 3, 4, 5 velocity values. So we have to add them up here. We add all velocity values and divide by how many they are. So they are 5. So I'm going to divide by 5. So once you add them, divide by 5, you get 20 meters per second. So the average velocity here is 20 meters per second. It means that during the 4 seconds of travel, the object had some velocities below 20, other velocities above 20, but on average, it was traveling at 20 meters per second. And as you can see, it's the midway number. So this one is the midway. It's actually the midway number. That's the average. It's the midway between amongst the 5 numbers. So its average is actually a midway number here and defines the average velocity of a freely falling object. You can also find the average velocity by simply adding the first number, the first velocity here, and the last velocity here. So this formula also can be useful. If you want to find the average velocity, just add v initial plus v final, you divide by 2, then you get your average velocity in this manner. So 0 plus 40 here, divide by 2, you get 20 meters per second, just like what you got here. So these are the same here because it's a different way of finding the average velocity. This is only applicable when you have constant acceleration, like free fall acceleration. We can make these conclusions for a specific case of objects falling freely. All right, so how about distance falling? Sometimes it is important to know how far an object has fallen. So remember the average velocity from the previous discussions. In general, average velocity is the total distance covered here divided by the total time taken. But also we just learned from the previous discussion or previous slide, we just learned that for constant acceleration, we can also find the average velocity using this formula. So it seems like we have 2 ways of finding the average velocity. So method number 1, method number 2. So we can actually say that these expressions, this expression here is equal to this expression because they are equivalent. There are different ways of finding average velocity for this situation. So I can equate delta D over delta time and equate it to V initial plus V final over 2 here. When I do that, I can now find out my average velocity using this method here. I know V initial from this one is 0 and V final is actually 40. So 0 plus 40 divided by 2, I'm going to get 20 meters per second. Then I equate it to this result here. Then that will give me actually how far the object has fallen. So we're here. So changing distance is actually the how far. This is the how far here. Divided by changing time is 20 meters per second. I can also put over 1 here or something. If I cross multiply, 1 times delta D is delta D here. if I cross multiply change in time times 220 meters per second, I'm going to get this result here. Now at this point, I have to go back and see how much time was that from the table. So from the table, it took 4 seconds for the object to fall. So I'm going to go back and say, okay, then this is the 4 seconds I have here, multiplied by my 20 meters per second. Then how far the change in distance will be 80 meters. So this is how far. Yeah. How far change in distance will be 80 meters. All right. So that's how we find how far an object has fallen when it starts from rest, when it falls freely. How about distance fallen in a different ways? How about finding distance fallen from rest using as just one is straightforward equation? Yes, there's a way to do that. And the equation is this one: distance, which we can also call delta D, is half gt squared. This expression, you can use it only for if an object starts from rest. So this is very important. If the object doesn't start from rest, you cannot use this formula. So only use it if you are falling from rest. If you apply this formula, you're going to see that G is 10 and our time is 4 seconds. If I use consistent units, SI units, if I use SI units throughout, I don't have to carry the units in the brackets. I can just put a 10 here and a 4 here, as long as I'm using internationally agreed units for G and time. So if I do that, I'm going to get 80 meters, the same answer that I got before. So you have different ways to find the distance fallen. All right, so we'll stop here for today. If you have any questions, please let me know. Bye for now.